Hi ladies and gentlemen, this is Mr. Green and this is another in my series of Algebra 2 lessons. We're continuing on with the progress that we've been making. We are well past Unit 3. We're in Unit 6 right at the moment, so you all should be working through Unit 6 trying to get some of your work done. What we're looking at today is called reciprocal power functions. Reciprocal power functions. So what we're looking at is the reciprocal of the power functions. We're looking at 1 over the power functions. So we're going to draw or describe the graphs of the reciprocal power functions and determine the domain and range of them and determine equations of the reciprocal power function. So what is a reciprocal power function? It's a power function, the denominator. Okay. The reciprocal power function is a power function that has a power in the denominator of a rational function. The function is described this way: f of x is equal to 1 over x. That's a parent function. Or g of x is equal to 1 over x squared. Or h of x is equal to 1 over x cubed. These are all reciprocal power functions. Okay? So let's go ahead and look at the next slide here. And what we have is we're going to graph one of them. To graph it, what I'm going to do is I'm going to actually fill in this t-chart over here. I've got my x and I've got f of x, which is 1 over x. And if I put negative 3 in there, my f of x is going to be 1 over negative 3. And if I put negative 2 in there, I get 1 over negative 2. And if I put 1 in there, I get 1 over negative 1. And if I put 1/2 in there, I get 1 over negative 1/2. Whoops, that's not a proper fraction. You invert and multiply, you get negative 2. If you put negative 1/3 in there, you work it all out, you're going to get a negative 3. Okay? So that means if I was starting here at negative 3, my value was 1/3. So it's like right there. Okay, my dot didn't show very good. There it is, like that. Okay, and if I go to 2, it comes up to 1/2, so it comes to right there. Okay, and if I went to 1, it becomes negative 1. It's right there on that point right there. Okay, I'm getting this. Okay, if I go to 1/2, it goes all the way up to 2. And if I go to 3, it goes all the way up to 3, or to 1/3, it goes all the way up to 3. So I'm beginning to see that it looks like it does something like this. Wow, okay. I do that one pretty good. Okay, what happens on the other side? If it starts out at a 1/3, it's going to be a 3. If it starts out at 2, it's a 2. If it starts out at 1, it's a 1. If it starts at a 2, it's a 1/2. And if it goes to 3, we go to 1/3. So basically, it's coming down the other side of the axis here, isn't it? It's doing this. It goes through 2, it goes through 1, and it goes out like that. Okay. So what we say when we're doing this is we say that f of x approaches the b value. Well, what are we talking about that b? Well, b is this value up here at the top. Okay? Whatever this is. It's approaching 1? No, that's not right. It's as f of x approaches infinity, the values of f of x increase without bound. So, I mean, as we're going this way, they're getting smaller and smaller, closer and closer to 0. And as it approaches negative infinity, it's getting closer and closer to 0 this way. But this one here, it's getting closer and closer to this y-axis here, isn't it? It's getting closer and closer to 0 this way, too. These are called asymptotes. Okay? It's the definition of what an asymptote is. Now, it's typically at this time that I would play something like MC Hammer's Can't Touch This. Dun, 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 can't touch this. Because that's what an asymptote is. An asymptote is a line that when you looked at it, you wouldn't be able to actually ever reach that line. And in this particular situation, we've got 2 of them that we would be looking at. We've got a horizontal one and a uh, vertical one. The horizontal line that I'd be looking at would be the line that goes right through here, x equals 0, because it never really y equals 0. It never reaches that y equals 0 line. Okay? The vertical one that I'd be talking about would be this one here, because it never reaches x equals 0 either. Because at x equals 0, we have to exclude it because you get a division by 0, don't you? Because if you put 0 in for x, you would get a undefined number. So it never touches that line either. So what we've got are two asymptotes. One of them is called a horizontal asymptote, which is y is equal to b, which is, in case you didn't recognize it, the equation would be, general equation that we'd be looking at would be f of x equals a over x to the nth power plus b. Okay? So they would approach b. I'm saying y because most of the ones parent functions we're looking at don't have a b value out here. So they do approach b, whatever that b value is, up and down. That's the way you shift it up and down. But this x to the nth would be something that would cause this to occur. Okay? That's the horizontal asymptote. It never equals 0 because I can't divide by 0 here, right? So we would have a vertical asymptote of x equals 0. So I've got two asymptotes. One of them is y is equal to b, whatever that b value is. In this case, it's 0. And then the other one would be x is equal to 0. Okay? Let's move forward here. Let's look at a couple of them here. Here I've got 3 over x squared. Well, I think the easiest thing to do to graph these things is just to put them in a calculator and graph them out. 3 divided by x squared. And when I do that and hit graph, it just graphs it out for me and shows me so clearly it goes like that. Okay? And so, yes, if you look at these values, so the second graph, the values of these that we're going to be looking at, you will see that at 0, there's an error, but there's a value for every other one. Notice how at 1 it goes all the way to 3. That's where that a came from there, right? But when it goes to 2, it goes way beyond that, okay? And it gets closer and closer to the y. It gets closer and closer to the y-axis at that point. So what we're looking at is, here in this graph, our vertical asymptote would be that x is equal to 0. Our horizontal asymptote would be y is equal to 0. Now, domain-wise, we have to exclude that x is equal to 0 from the domain. For the range, obviously it doesn't ever go down here in the negative, so it would be all x values greater than 0. Okay? How about this one over here? 5 over 2 x to the third. Okay, well, let's change our equation here, and we'll erase this one. We'll make it 5 divided by 2x to the third power, and we hit graph on that, and we get something that didn't look right there. Let's try that one again. 5 divided by 2x to the third power. I don't think it's right. Let's see here. 2x to the third power, and we'll put parentheses around that, and delete that, delete that, that. I'm wanting to delete you here. 3. Thank you. It's not letting me delete the thing I want to delete. Okay, there it goes. Got it that time. 3 parenthesis, and now, never seen a parenthesis inside of the thing there. Didn't mean to do that. I meant that parenthesis to be right there. Thank you. Now when we hit graph, it thinks about it. That's what I was thinking I should have wound up with. Okay? And what do we have at this point? Well, if we look at the table, second table, we're going to see at x equals 0, we got an error. These values never really ever reach 0. If you go down these and go all the way down, I mean, you can keep going through these numbers all you want. They'll never reach 0. They get very small, but they never reach 0. So once again, an asymptote at x equals 0 and an asymptote at y equals 0. Okay? You know what? One of the things I noticed there when I was doing that, I don't know if you noticed it or not, but this one did this, like that, and this one did this, like this, like that. Interesting. You know what? I just by inductive reasoning, even powers are going to be the same direction like this. They're both going to point up as they get closer to 0. Odd powers are going to point in opposite directions, one up, one down. Why is that? Because we're multiplying negative numbers here, right? Negative times a negative times a negative is going to put me in this quadrant down here, and the quadrant 3 down here. But a negative times a negative would still leave me in quadrant 2 up here when I'm squaring. So odd powers are going to be in opposite directions like this. Even powers are going to be in the same direction. That's the way I always remember it so that I can look at it. If you look at these graphs, here's one up here at the top that is to the third power. Okay? And you can see they're going like this and going out like that. Now, what they're trying to show you here is that if you change that value of a, it just expands it and stretches it a little bit, okay? But it's still going to have the y equals 0 as the, I'm sorry, the x equals 0 as the vertical asymptote. Down here, the a value just is going to stretch it out just a little bit further, but it's still going to have that x equals 0 as the vertical asymptote. The negative sign in front of everything just kind of flips it, rotates it around the x-axis so that it rotates around just a little bit. Okay? So let's look at this one here. It says find the domain and range of this one. Well, this is really not that difficult. I'm not even going to have to do much of graphing on this one. For the domain on this one, I'm going to say all x values except for such that x is an element of x not equal to 0. I can't have 0 in my domain. Why? Because I can't divide by 0. Well, they're q's, but that's still. I can't have 0 in the domain. As far as the range is concerned, it's an even number, so it's going to be all q values greater than 0. Okay? And that's just a greater than sign. It's not a greater than or equal to. Oops. Well, let me erase that one. But that's just a greater than sign. Greater than. Q has to be greater than 0. My range will always be positive. Okay? Does everyone understand that? I hope so, because see, I had an even value here. That's how I knew what my range would do. So one more graphing here. How would I graph this one? Well, you know what? I don't even have to spend too much time working with this one. When y is equal to 1, and this is, even though it is a y here, this is going to be the y-axis, and this is going to be the f of y. Okay? They trick you this way when they're trying to get you this. I know that if I stick a 1 in or 0 in for y, I'm going to get an undefined number, right? If I put a 1 in for y, it's going to go through 3 over 4. So at 1, it's going to be 3/4. That means it's going to go right in here somewhere. Okay? And if I stick a 3 over 4, if I stick a negative 1 in there, I'm going to get the same thing, 3 over 4. If I stick a 2 in there, 2 to the 6th power is 2 times 2 is 4 times 2 is 8 times 2 is 16 times 2 is 32 times 2 is 64 times 4 is 256. So I'm at 3 over 256. Oh my goodness. That's going to be some little bitty number. It's going to be like that. Okay? So my graph's going to do really close to the x-axis here and come up to here. And then I know just by looking at this, it's going to do this, right? So at 1/2, it's going to be, oh my goodness, that's going to be 256, or I'm sorry, 64, 4 over 64, that's 1 over 16. That'd be 16 times 3, that'd be 30, 48. It's going to be way up there at 48 by the time it gets to 1/2. Wow, that's a huge number. Same sort of thing on the negative side here. It's going to do this. Like that. Okay? You guys seeing how these are graphed and how these are done? These are the power functions, and we're going to be looking at the inverses of them too. We're looking at the inverse of the power function. So they do graph out kind of strangely. Okay, final question I'm going to ask you here is, well, having looked at them, can we look at a graph with just one point on that graph? Can we figure out the power function? And the answer is yes, we can. I'm given this -2 as my x value. So I'm going to take this power function here, and I did recognize that one going up, one going down. It has to be an odd function, an odd variable down here on the bottom. So basically, I'm going to say -2 divided, oh wait a second, -2 to the 3rd power, and that's over a, right? And so if I say that's equal to 1 over 24, I can solve that equation for a. Okay? This is -2 to the 3rd power. That's a -8, right? So I'm going to get a is equal, or 24a is equal to -8. And if I divide by 24, I'm going to get that a is equal to -8 over 24, which is equal to -1 over 3. So I found what a is. So now let me write that down. Well, a is -1 over 3 divided by a to the 3rd power, or x to the 3rd power. Whoops, wait a second. I got a fraction in the numerator here. What you're doing when you're doing that is you're actually saying -1 divided by 3 x to the 3rd power. Okay? Now I want to point out a couple things. First of all, see how it's down here in quadrant 4? The graph is? This graph here is in quadrant 4. Well, that told me right away it had to have this negative sign here. Okay? The fact that they're pointing in opposite directions like this, one's in 4 and one's in 2, that tells me that it had to be something like x to the 3rd. Okay? It could have been x to the 5th, but I used x to the 3rd. Okay? Then, using this point 124, I'm sorry, -2 over 1/24, I simply set that equal, and I was able to find what the value for a was. And that would be the graph of the function that I'd be looking at here. So k of x is equal to this. That whole thing. Okay? So, having done that, if you guys have any questions, feel free to come to Toga. Ask questions Monday through Thursday, 3 to 4 o'clock. I'm there for you guys to answer any questions you might have. And then I'm also there on Fridays sometimes. I have outing last Friday, so I wasn't there last Friday, but I'm there most Fridays to answer questions also. Okay? Looking forward to next time we meet, and I'll talk to you then. Bye.